Okay, let's do some problems from Chapter 8. Suppose a disk rotates through 3 revolutions in 4 seconds. Okay, what is its displacement in radians in this time? What is its average rotational velocity in radians per second? Alright, so we have a disk. It's going to go around. It's one time. It's going to do that 4 times. It's going to do that 3 times in 4 seconds. It's going to go around 3 times. Well, if we're looking at the degrees of this circle, that's 360 degrees, right? 60 degrees. Well, if you look in your book, a radian, or 2 pi radians, is equal to 360 degrees. Alright, so we did, which is equal to 1 revolution. I should say that. So we did 3 revolutions. And I want to convert this this is what A is asking. I want to convert this 3 revolutions into radians. Alright, so if I go 3 revolutions, well, for every 1 revolution, I have 2 pi radians. Revolution cancels out with revolution, and I have 6 pi radians. Okay, so I answered A for you. Now let's do B. What is the average rotational velocity in radians per second? Well, you have the radians here. You were given the seconds. Just make sure your answer has the unit of rad per s, radians per second. I'll let you plug in the math. You're going to take your radians and divide by your time. Okay, let's do another one from Chapter 8. The rotational velocity of a merry-go-round increases at a constant rate from 0.6 radians per second to 1.8 radians per second in a time of 4 seconds. What is the rotational acceleration of the merry-go-round? So the rotational acceleration is equal to the rotational velocity initial, or final I should say. Let's go rotational, and this is final, minus the rotational velocity initial, there's I there, divided by the time that it takes to change that velocity. Similar to acceleration equals Vf minus Vi divided by t. Okay, we're just dealing with something going in a circle now. So let's write out our knowns here. We know the rotational velocity. Oh, I should use W. That's what your book uses. I'm sorry. Let me put in there. So our rotational velocity final is 1.8 rad per second. That's what we have here. And it started out with rotational velocity of 0.6 radians per second. And the time that it took to do that was 4 seconds. Okay, got all of that from our problem up here. Now I take my, and I'm looking for the acceleration. Actually, your book uses, I think this is what your book uses. It uses alpha. Okay, so we're going to plug into this equation alpha. Let me rewrite it. Alpha equals the final rotational velocity minus the initial rotational velocity divided by the time. We're going to plug all this into here, so take 1.8, subtract your 0.6, divide by your time, and radians per second divided by second is the units that we want. This is radian per second divided by seconds. I'm just looking at the units right now. So our final unit would be rad per second squared. Okay, this is just looking at the units. This is the unit you want. So your alpha will equal whatever number that is from doing your math, and with a unit of rad per second squared.